Last section was about all law of sines, and we had that nice formula for it. We found out most times there's either 0, 1, or 2 triangles. Question, Jackie Bars? I'm sorry, did they all get handed back, or did I just miscount? All right, sounds good. Math teacher miscounting, that's great. I love it. All right, guys, today, 2 things you really need to understand here. Law of cosines, our goal is to use law of cosines to solve triangles. So again, we're trying to find all 3 angles, all 3 sides. Now there's 2 conditions in which you're going to really talk about, and I'll get here in a second. But guys, it says the law of sines is challenging because when you are given a side and its angle on another side, it doesn't have to make a triangle. It might make one triangle, it might make multiple triangles. Today when we look at law of cosines, we really don't have that problem. Okay? 3 basic formulas that you need to know. Law of cosines, right here. Keeping in mind that small a, small b, small c, those are all sides of a triangle, right? And then capital A, capital B, capital C would be any angles in this, okay? Guys, the law of cosines, there's 3 different formulas up here, but don't let that fool you. What's really going on here is the same exact thing all the time. What I really want to point out is this. This is saying that a third side of a triangle can equal the squares of the first 2 sides minus 2 times the other sides times the cosine of A. What I want to highlight or underline here, what side is listed here? A. What angle is listed over here in this part of the formula? A. What's listed here? The B. What's listed over here? So whatever the side is, you're going to have the side here and finally the angled end with everything else is going to go in the middle here. Does that make sense? Okay? So those 3 formulas really mean the same thing. It's just going to be dependent upon what information they give you in order to make this work, all right? Okay, once again, this is going to work for what? Any triangle, but you can only use it when you are given 2 sides and the angle between them, or all 3 sides. This part right here is very important, okay? It says when you are given 2 sides and the angle between them, or all 3 sides. I want to kind of make a note. I'm going to put this right up here about what this is talking about. The 2 conditions in which this works is the following. When I talk about the 2 sides of a triangle that you need to have in order for law of cosines to work, you might have something like this. You might have side A, side B. You would need angle C then, right there, okay? You need the angle that's between the 2 given sides, all right? So I always say that this is like a side angle side situation. The angle is included between the 2 sides, or the 2 sides make up the angle. Do you see what I'm saying right here? Side A and side B, don't they make up angle C right here? Okay, so in this right here, when it says you need 2 sides and the angle between them, that just simply means you have a side angle side setting, okay? The angle is formed from the 2 sides put together. Does that make sense? If I had this side and that angle, would it work? If I had side A and B and then this angle that I'm pointing at, would that work? No. The 2 sides that I have to form the angle that I'm going to use in this situation. So do you understand what I mean? You have to have a side angle side setting in order to make this formula work? Good. A few bobbleheads in here. That's good. Okay. All right. Then the other condition in which this is going to work will be when you know all 3 sides. You know your side A, you know your side B, and you know side C, Mr. Parson. All right, so you have all 3 sides. It'll work then as well, okay? You'll have all sides and that'll work as well. Okay, so down below again, I'm going to read that paragraph. It says, once again, this works for any triangle, but you can only use it when you are given 2 sides and an angle between them. That's the side angle side setting, or all 3 sides, the side setting, okay? Now, as we work our way through this to solve triangles, don't lose sight of the fact that we just got done with law of sines, because we're going to use law of cosines to help us move along, but law of sines might be something that can help us solve the rest of the triangle along the way too. All right? So let's go ahead and look at an example. Let's see if we can't figure this out. In this example right here, it says solve triangle ABC if my angle A is how many degrees, guys? 39.5. B is? And C is what? Okay, this is what I'm saying is a side angle side setting. I'm just going to make a generic triangle here real quickly. I don't care what this triangle looks like. Might look like this. Go ahead and draw that triangle real quickly, okay? I'm going to say that this distance right here is my 12. This distance down here is maybe my 14. Okay? So my angle A, let's see, if this is side B right here, isn't this angle B down here? If B is 12, wouldn't angle B down here? Opposite. If this length is 14 right here, doesn't that make this angle what up here? Angle C, right? So what's this angle have to be? Angle A. Do we know the measure of angle A? Yeah. Okay, no probs. What is this angle measure right in here? How many degrees? Okay, so those are the things that I know. Guys, do the two sides that you know make up the angle, you know? So that angle's in between the two sides, right? So this would be my side angle, side setting. So my question is this, can I use the law of cosines to find something? I can, can't I? All right. Here's how this is going to work. What side don't you know right now? Side A. That's a bad looking A. That's pretty BA. All right, never mind. That was bad. Badass. Yeah. All right, I'm DUN done. Or DUM done. Which one is it? I can't figure it out. All right, let's find side A. I can use, here's the deal. I can use law of cosines here to find side A. All right. So here's how this is going to work. And this is what we got right down here. We should use the law of cosines. That's what that stands for. It's not the Loch Ness Monster. By the way, did you guys watch that Python thing? Or the Anaconda thing?
That guy ate himself.
That guy that got in the suit and...
Yeah.
Did you watch it?
I watched it on
What?
vacation.
What are you talking
That was
about?
a joke.
He let it.
He had like this carbon fiber suit, put it on, and he was going to let this big anaconda from the Amazon jungle eat him alive.
Why?
Because they wanted to, well, the thought was that this suit would measure the, when that anaconda constricts him before it kills him and eats them, they wanted to know how much force is really there, okay? Well, they had this carbon fiber suit on him all the way around, and it was going to be okay, but he's like, I'm not mobile enough in my arms and my legs, so he took part of the suit off, okay? He had his whole head covered, his whole upper body covered. That snake, it went right around his rib cage and started compressing him. And what they really wanted to get were the numbers on the compression for him, okay? They had said before that the most they've ever measured before was like 90 pounds per square inch. So if you can imagine a square inch may be, well, that's a big inch. Square inch is about that big right there. Okay, they said that when they got this snake on him, when they actually did it, when they found this, it was like a 22-foot snake, and started constricting him with that carbon fiber suit on. That thing measured 300 pounds per square inch around him. So basically saying that when he was getting crushed on that suit, it'd be like 300 pounds in just that little area, forcing down over his whole body, okay? Well, I said that he was feeling like he was immobile, so he took his arms and he took his legs part off, and I was like, cool, the snake's gonna start eating him. It started going to the top of his head, and they got the camera inside of his mouth. Well, the idiot didn't wear his arm, so he tapped out. He's like, okay, guys, come get me. He's going to break my arm. I was like, hour and a half of watching him go through his jungle like, with a sword, like Indiana Jones, going through here. And he starts getting eaten, and he taps out. I was like,
I don't get it.
He said his arm got so constricted in there that he said if they don't get people in there to get that snake off him right now, it's going to snap his arm.
I thought he wanted to get eaten.
He did, but he had to tap out because he was in so much pain already.
How did they get him out, though?
The snake only got up to about part of its head. He said, okay guys, I need you. About 40 guys rushed in and started pulling the snake off of him.
Wait, what do you mean only got that far up to his head?
I mean, if this thing came over his head, his mouth got about down to here, the snake's
So
mouth.
doesn't the snake have to like
Because it was
dislocate
wrapped
its
around
jaw?
him.
The whole snake was
Oh.
wrapped around him, and then the snake, the other part of the snake comes up and starts eating him from the head down. And
So instead of
so he's all wound up here, so as he's eating it, he keeps unwinding little by little by little.
How is he going to get out if he made it all?
They figured he would regurgitate the thing, because they showed one regurgitating an alligator.
Wait,
They're
doesn't
just
a snake
assuming
have to
that.
like dislocate its jaw to eat
They have
something
knives.
bigger than itself?
Snake's jaw can go like this. It can actually go back further than 180 degrees.
Yeah, that's
So
what
like
I
the top of
imagined.
its head
Like in there and
can
all
be up
the
here, and yeah, it's more, yeah.
kids in there.
Anyway, all right. You know what I say? There's only one kind of good snake. There's only one kind of good snake. You know what that is? Dead one. Ugh. All right. Anyway, let's back to law of cosines. Why did I get going on that? I don't remember. But oh, I know what I wanted to say about this other snake. He said that one snake that he caught one time. He said that when he jumped on its back, he went to put his arms around it to go underneath his belly like this. He said he couldn't even get his arms all the way around. If you can imagine me, that's how wide that thing is. And then imagine 42 feet long now.
Wait, what kind
That
of
wide, and it's an anaconda down there. And he said 42 feet long, so take like our biggest bus that we have in our school district. That's how long that snake was. Yeah. It's awesome, isn't it? Okay, back to this right here.
No, the plan was to get eaten.
Oh, I know how I said snakes. I thought this was Loch Ness Monster. And then I started thinking, all right. Anyway, right here, it's going to tell us first to use the law of cosines to find the side. What here, guys? A. All right. So I'm going to kind of scroll up here a little bit. Let's find side A. So I'm going to go ahead and find the formula that allows us to find side A. Now, you could use this right here, but I have to use this one right here because the only angle that we really know is angle what? A. So I'm going to use this right here, okay? We're going to use my angle A to find side A. All right? This 12 really is a distance of B and C is 14. So here we go. I'm going to use this top formula. So I'm going to start this out as A squared equals. All right, what's the B value you're going to plug in using this formula?
12.
12 to what power?
Squared.
Plus
14 squared.
14 squared. Minus 2 times, what's the B value?
12.
Times the C value. 14 times the cosine of how many degrees? Cosine of 39.5, right? I'm going to back away here. A squared is equal to, this is my B squared part, right? Plus my C squared part, minus 2BC cosine of angle A. With me on this? With me on this? Okay, so let's do a little bit of calculating here. All right, here we go. This becomes the following. A squared is equal to, 12 squared is $1.44, isn't it? Plus 14 squared, 196. Minus, okay, here's how I would handle this part over here. Do I have an angle measure right here? Do I have an angle measure right here?
Yep.
I would handle this all in one step. I would do the cosine of 39.5 first and then multiply everything out. So go cosine of 39.5. So I'm going to go 39.5, cosine that out, times a 14, times 12, oh dang it, times 12, times the 2. What do you guys get for a value? Do you agree with what I have up there? 259 point, should we just call it 259.3 or do you want to go two places? Just two places? Okay, we'll call it 259.27. You understand where that value just came from there, gang? Good? All good? Okay, so I'm going to go ahead. I can go ahead and combine all these. So let's go 144 plus the 196 plus 259.27. And are you guys at 599.27 like I am?
You're gonna do 259 instead of
Did I screw up?
600.
Okay, let me start over. 144 plus 196 plus 2.
Minus.
Yeah. Me smarter than the average bear. Watch what I do here. We'll call it a negative value. How about 80.73? Do you like that better?
Yeah, you got screwed.
Jeez, Mr. Person. What was the number? 80 point what?
7.
This stupid dot right here in the middle of the board gets me there. 80.73. So what are you going to do with 80.73 to find your A value? Root it out. Okay, root that. Okay. So get this bargain sneaking bastard out of here. All right. What's your A value?
9, roughly.
Let's go two places. 8 point what?
9, well, it's wrong. It's 8.985.
So 8.99.
Sure.
Gnarly. So we got our distance here, right? Now, here's the deal. I'm going to ask you a question here. You guys understand how I got 8.99 using law of cosines there? All right. Here's what I'd like to say about this now at this point. Is that formula pretty long or pretty short? Chance of making an error pretty high or pretty low? Can happen in a hurry, right? We always talked about last section in law of sines. It said, you know what, if I have an angle and my side, meaning capital A, little a, or capital B, or capital C, little c, we can use law of sines to finish the rest out, right? Before I put that 8.99 up there, did I have an angle and its side? I did. Once I've established 8.99 from law of cosines, do I have an angle and its side? So where can I revert to now to finish the rest of this problem? I can go back to law of sines, right? As soon as you have, and this is my suggestion, as soon as you have an angle and its side, start working law of sines afterwards, okay? So take a look at what I've got here, kiddos. This would be like my step one right here, I'm going to call it. And that allowed you to find side A. So now, let's just maybe say, well, what about side 2 over here? So maybe right here, let's just call this step 2. I do have an angle on its side right here now, don't I? Okay. So I could say 8.99 is fall off any chairs lately, Mr. Riggs? True story, Mr. Riggs. He fell off with my chair. He was just sitting there and he fell off, all right? I was wondering if Braxton is falling off his chair. Valid question.
Without the help of
Who? All right, here we go. Do you guys agree that I can use this side in its angle right here?
Yep.
All right, so I'm going to say 8.99 is to the sine of how many degrees, gang?
39.
Sine of 39.5. Let's use this to find angle B. So I would say as my length 12 is to the sine of angle what? All right, so let's find the sine of angle B here quickly. I'm going to cross multiply and divide, so let me pull my calculator up here. I would take 12 times the sine of 39.5 divided by 8.99. So we'll see what that is. So I'm going to go 12 times that. 12 times the sine of 39.5. Sine that out. Hit equals. Okay. And then I'm going to divide that by 0.899. Or 8.99. And I come up with a value there. Now, it's about 0.8490 for sine of B. What am I going to do to that decimal now to find my angle? So I want to invert this, right? So I'm going to do the sine inverse because we're using law of what here? Okay, law of sine. So I'm going to invert that. So, oh shoot, how do I do that on this one? Invert. Inverse sine. I'm coming up with 58.11 degrees. Are you guys getting the same? Yes? If anyone's punching that in, did anybody get 58.1?
Yeah.
I went this times this divided by this, right? And I gave you that decimal right there, right? So I'm going to do the sine inverse of that because we're looking for an angle measure. So I'm going to go sine inverse of 0.8490 on that. Did you get something pretty darn close to this here? Okay. So by this right here, angle B is how many degrees, guys?
58.
Okay, the beautiful part about it is this. Once I know the second angle, we can easily find your third one here. Okay? So in this case right here, you got a side angle, side setting. I'm saying find the other side first. Once you find that third side, law of sines your way the rest of the way through the problem. Okay? Doable? Making sense?
Yep.
Okay? What would that third angle be if you would add these two up and subtract from 180? Did anybody punch that far ahead of me? 82.38. 39. You guys want to know a nice thing about law of cosines? One solution. all the time. None of the 0 crap, 1 crap, or 2 crap, okay? Well, I should say 2 crap, because 2 really is crap. Number 1's just, all right, but never mind. Guys are not so much. All right, roll. Here we go. Next page. Did you guys have all that down? Okay. Second page here. Here we go. Here's an example right here. All right. In this example right here, it says solve triangle ABC if you know the following. It says side A is 19, side B is 24.3, and side C is 21.8. So what 3 things am I giving you this time? 3 sides. So this would be the setting of a side, side, side setting. So the 2 settings that you will always use, your 2 settings that you'll always use for law of cosines. You have a side angle side setting, or you have a side, side, side setting. That's how you know when to use law of cosines. Okay? So in this one right here, there's a rule. It says when given all 3 sides, try to find the largest angle first. I don't care which angle you find. It makes no difference which angle you find. Okay? Once you find an angle, you should be good to go. Now I understand why they're saying find the largest angle first, and we're going to kind of follow this. But right down here, there's kind of a note. It says the largest side should have the largest what? Angle. Okay, what's the biggest side here?
B.
Side B, right? Everybody agree there? Side B? So help me out here. First angle I'd really like to find here, according to this here, when we do this, is angle what? B. So let's do this, all right? If I'm going to use angle B to find, am I going to use the first formula, second formula, or third formula? Second one. It's going to be B squared equals A squared plus C squared minus 2AC cosine B. We're going to find angle B first, right? Because angle B is opposite the longest side here. Would you guys buy that? Okay with that? All right, so here we go. I'm going to write the formula down here quickly. Let's get this taken care of. I'm going to say little b squared equals little a squared plus, little a squared plus little c squared minus 2 little a little c cosine of angle B. Guys, what was given in this problem again? All 3 sides. This is a situation where the one thing we're not going to know is going to be angle what? B. If I'm looking for an angle this time at some point or in the very end, what are we going to have to apply? Some kind of an inverse. Yep, some kind of an inverse. Let's fill in what we know. What's taking the place of little b? 24.3 to the second. Plus, 19 squared plus 21.8 squared minus 2 times, all right, what's taking the place of A again? 19 times C, which is 21.8 times the cosine of, do we know angle B, guys? No, angle B is going to be our unknown. All right, there's a lot of number crunching going on right here. Again, once you've applied law of cosines, go right through and apply law of sines afterward. So let's check it out.
Wait, why do you have?
I messed up. I should have an equal sign right here, shouldn't I? Okay, give me a second to clean that up. Did I screw anything else up here? I should have an equal sign right here, shouldn't I? Okay. How about the rest? Yeah. Okay, we're good. All right. Anybody have 24.3 squared for me yet? About 580.
590.49.
How much?
590.
590.8. Oh, my math isn't very good, but is 19 squared 361? Yeah, it is. All right, I need someone to square 21.8 squared for me, please.
479 or 475.24.
475.24. All right, this one here is part, we said go ahead and try and calculate the whole thing. You guys agree on this part right here? The only thing I can calculate is that part. So somebody punch up 2 times 19 times 21.8, please.
It's like 828.
828.4
Yep.
times the cosine of b. I feel like I'm missing out on something funny. I don't know. Okay. You guys agree I've got everything punched in there correctly? All good?
Do you do anything with the equals sign?
Yeah, I fixed it right here.
I mean, like, you don't incorporate that into your problem, do you?
It's just all part of the formula. Good there? All right, we've got some stuff to do here. Now, guys, I want you to be very careful on this right here. This part right here says 828.4 times the cosine of what here? B. All right, keep that in mind. The only thing I can really accomplish right here or really do is add that stuff up right there. Do not put these first three together. All right? Because the cosine of B is going to be some number. It's not just this value right here. So watch what happens here. This becomes 590.49 equals, somebody add these two up here for me. 836.24 minus 828.4 times the cosine of b, right? Now, big, very common mistake that kids make all the time when they do this is they want to combine this and this. Would you guys combine this 12 minus 5x? Would you combine those to make that 7x? Then don't do it here, because this does not have a cosine b. This is not 836.24 cosines of b, and this is not 828.4 cosines of b. All right? Don't put them together, because they don't have like terms, do they? Just like you wouldn't put 12 and minus 5x together, you can't put this and this together. Everybody understand what I'm saying here? Do not do that, because every time I see kids do that, all right, it's like a sport. That you have a lead in and you blow it in the last 3 seconds or something like that. That's also known as Minnesota Vikings football, all right? Okay. So here's what you need to do. You got to get this 836.24 out of here with another constant. So I'm going to subtract that value from both sides, gang. So watch what happens. 836.24. Subtract it from both sides. Again, what are we setting out to find right now? Okay. So these would cancel right here, wouldn't they? And do you guys agree that the right side is going to be negative 828.4 cosine of b? And on the left side, what's that difference right there? What is the 590.49 minus 836.24? Negative 295 point.
Negative 245.
I typed in, yeah, I typed right.
Negative 200 and
45.75.
okay. Think of the cosine b as like an x. Cosine of b is like an x. What could I divide both sides by? By the way, what kind of 828.4 should I have here? Negative. So this should be negative right down there. Okay. What are you going to divide both sides by now to get the cosine of b all alone at this point?
You got just the negative.
You're going to divide both sides by negative 828 point. Okay. Over here on the left, somebody give me that decimal quickly.
0.29665620.
It's just 4 places will work.
0.2966.
0.2966.
Yep.
That is going to equal cosine of what here?
B.
Because these would do what to each other now? All right, kiddos, we're getting close here. What am I going to have to do to that decimal? I didn't know what angle B is at this point.
Inverse cosine.
Would you go cosine inverse on this one? Don't go sine inverse. We've been doing a lot of sine inverting, right? What formula is up there right now? Well, it's saying cosine of b is equal to 0.2966, right? So cosine inverse this time. Make sense to everybody? Okay, so let's do that. Do it. Do it. Inverse that cosine And you get a bunch of hippy dippy baloney at 72.74, right? So angle B is how many degrees, kiddos? 72.74. Angle B. Guys, there's a lot of number crunching going on here, isn't there? Lots of number crunching going on. So I'm going to run back to the top here. Wow, there's a ton of work there. Holy cow. What did we say angle B was? 72 point what?
74.
Now here's the deal. You don't necessarily have to go this route right here, but I had encouraged you guys to say, you know what? Find the largest angle first. All right? Which would imply that angle A and angle C better be less than how many degrees? 72.74. All right, hey, once you've law of cosigned your way to find one other part, what are you going to apply afterwards? Law of sines. Let's use the law of sines to find angle A. I'm going to put that right up here. So I'll say my step 2 is up here. So let's law of sines our way out on step 2. Here we go. Let's find angle A. So I'm going to say 19 is to the sine of angle what?
72.7.
Just the sine of A, isn't it?
Yeah,
19 is to the sine of angle A, as 24.3 would be to the sine of what was our angle? 72.74? All right, so let's punch this mess up and see what we've got here. Let's see, I would go 19 times the sine divided by 24.23 first, right? And we're going to get a decimal, and then we're going to have to invert that. So help me out. 19 times the sine of how much?
72.7.
Equals. And then divide that by what, gang? 24 point. Why did I put 2, 3 here? That should be a 24.3, shouldn't it? Because that was our distance. Okay, so make sure you didn't copy it down the way I did. I'll come back and change this in a second, but make sure that's a 24.3 right there. Okay, I've got that right there. That's a decimal. Do I need to invert this or not invert this?
Yeah.
Invert this because we're looking for an angle. What kind of inverse this time? I got a sine inverse this one because we're using law of what? Law of sines right here. Okay, it's telling you right here. Sine of A would equal that decimal. So we're going to invert this sine-wise. And I get 48.3. 48.3. Is that what you guys got? Okay, so 48.3 is angle what? I want to make the change right here so that you guys didn't copy this down. So give me a second. That should have been 24.3 right here. Okay. Hey, are we almost done? Do I need to do anything else? Angle C. I can find that. Add them up, subtract them from how much? 180. Let's do it. 180 minus 48.3 minus 72.74. I got 58.96. How you guys feel?
Yep.
Okay. Hey, by the way, just a quick question. 58.96 degrees here. The rule said that the longest side would always be opposite the largest angle. Is that the truth here?
Yep.
Hey, here's a question. C was the second longest side, wasn't it? Isn't that across from the second largest angle? Isn't A the shortest side? Isn't capital A the smallest angle here? Okay, you see the correlation in that rule right there? Okay, what are the two cases where I can get away with using law of cosines to start my problem? Side, 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 or side, angle, side. Once you've applied the formula once to find the rest of the triangle, or I should say solve the rest of the triangle, what are you jumping into for step 2? Law of sines. Questions about this? Going uno. Going dos. El solde. All right.